fellow humans. This one will be a bit of a trip and a troll, Canadia sparsa. I'm gonna start from the beginning of the discovery, kind of like where, significance, location, originally found, and I'm gonna give a little bit about the dating methods. You have some rough knowledge on how we got to like the ages, some of the bigger numbers that we got, kind of what was going on, Cambrian, the content of the BURGESS shale, which I'll explain later. Talk a little about that and give a good rough, give a basically a description of it. And give a good rough, give a basically a description of it. And give a good rough, give a basically a description of it.
That's called foreshadowing.
Let me introduce you to the BURGESS shale. This location is pretty much a star, if the location can be a star for this, for Canadia sparsa. It's located in the Canadian province of British Columbia. It's a hotspot of incredibly well preserved specimens from the Cambrian explosion. And the incredible part is this includes animals with soft parts. That's usually because the hard stuff, like bones, are preserved. The soft parts usually decay or just don't mineralize. The animals were probably quickly buried in small landslides, basically sheltering from effects and preserving them until they got exposed relatively recently. I mean, geological time scale, humans aren't blinking the eye. But the dominant animals found here are arthropods, but other animals are also found in large numbers. The the BURGESS shale is part of a landmass continent called Laurentia. Okay, this time map is not exactly to scale, but it shows you about where the Cambrian period is compared to everything else. It's kind of right there. Uh, the beginning of this time, there's a little bit of a debate about it. The International Commission on Stratigraphy has it about 541 million years ago. They chose that time because of worm burrows that really was found at the time. They came out in huge numbers. The end of the Cambrian mass is at the Cambrian mass extinction event 485.4 million years ago. The mass extinction is basically where everybody declared, figured where the label of the Cambrian period. That's when it ended. For a little context here, in the Triassic age of the beginning, the dinosaurs would have to wait somewhere about 240 million years later. This is roughly the same time from now to the beginning of the Triassic period. Give or take. I'm having a little fun with that. But okay, remember how I said with the numbers, like how did we get there? Let me explain. Okay, so we got radiometric dating. I'll get to that to a moment, but I want to talk about index fossils first. Kind of going off script a little bit. So index fossils are found basically all over the world. Um, if you have a particular species of trilobite, for example, if you find it off, let's say in England, and you find the same species somewhere in, I don't know, Washington State in the United States, you can generally infer from that those two rock formations are about the same age. But to get the actual numbers, you need stuff like radiometric dating. See, this is the stuff that makes carbon dating famous. However, for our purpose, since it's reliable, carbon dating only goes back about 50,000 years or so, is uranium to lead dating, which is commonly used for dates as far back. I'm going to give an oversimplification of this. There's different types of radiometric dating, and the science gets kind of crazy on that. So in an atom, you have electron shell around it, which is important for chemistry, but we're talking about more about nuclear physics here. So in the atomic molecule, you have the nucleus, which has protons and neutrons. Protons dictate the type of atom you're looking at, like one proton is hydrogen, six is carbon, and now you have different isotopes of those atoms, and the different isotopes have different amounts of neutrons. So for it to be stable, they're generally with the same amount of protons, plus or minus a few. And it really varies on the element you're looking at. So stable elements are stable. It's important for other things, but it's not interested what we're interested in here. So when I say stable, I mean they don't like to decompose like unstable elements. So when you hear that you're drinking the same water as dinosaurs, the same hydrogen and oxygen elements and all that, if they're stable, there is a good chance that the same water you're drinking, the oxygen and the hydrogen elements, they're probably the same. There's truth to that. So look in the chart right here. When an element decays, like uranium into lead, there's a neutron quitting and taking a proton or few with it. Again, there's a lot more details. There's different types of decay, but like this chart is showing how uranium can break down to lead. Again, not all isotopes, just the ones we're looking at here. So going back to the Burgess Shale, it was part of Laurentia. Basically, modern day North America, maybe some parts of Europe. This continent was by the equator and really tilted 90 degrees. There was warm ocean currents surrounding the continent, so it may have been fairly tropical. And evidence for this, including the tilting of the continent compared to how it is today, is how the magnetic crystals formed in the igneous rock and the types of sedimentary rock that formed around the continent. For a quick recap, igneous rock is a rock that's formed from stuff like volcanoes. And sedimentary rocks are the rocks formed from the breakdown of other rocks and solidified, so basically sand turning to sandstone. And sedimentary rock is where the fossils are generally found. So, what about the life at the time? Well, we're looking mostly aquatic life. The first fish started showing up at the end of the Cambrian, so it was heavily dominated by arthropods. So, Canadia sparsa is a polychaete worm like this, which is an annelid. Annelids are segmented earthworms, or segmented worms. Modern earthworms are annelids. Even though it was discovered in 1911, there is not a scientific illustration of it until 1931. The thought it is filter fed with one rows of tubes on their backs to do the feeding, with the legs being weird spiked stilt things. There's nothing like this today. So the legs kind of the spikes being legs was a little bit debated, but this is really beginning of known multicellular animal life. This could be possible. Uh, there was a lot of worms. We don't know exactly what was on Earth at this time. We knew some stuff, but we didn't know like the full ecology of what's going on here. So in 1977, Simon Morris published a paper with a few discoveries. First, it had a club head or butt. We didn't know which way was which, you know. So we did know it was not an annelid worm. So that means the genes changed into hallucigenia. The rest, yeah, we're not sure. There was a theoretical idea about the locomotion, and he pointed out this made very little sense. There was there was a bit of debate on if the legs were spines, which way was up, which way was down. There was really no strong evidence one way or the other. He even had a picture of like how the legs could be the spines. And since then, there really hasn't been any. So in 1991, a paper by these two, I'm not gonna, I'm not gonna try, changed a few things. In China, there's a place where you can find fossils from this period of time, in the Cambrian period in Xinjiang, which is in southern China. These authors are making connections between hallucigenia and a couple armored lobopods. So hallucigenia is right now is basically considered a lobopod at this point in time. And with this information, this is the best that us humans could do. So here's a reconstruction of hallucigenia on top with an unnamed lobopodian at the bottom. The similarities were evidence that they had two black legs and the spikes were actually on top. This is similar to looking at like a porcupine armadillo with these two, with Hallucigenia being the porcupine. So, what is a lobopod? Lobopods are close kin to arthropods, with both of them being part of Excosia, which are animals essentially that molt. Tardigrades and velvet worms are sometimes considered lobopod because part of the classification involves limbs that are more similar to tentacles than to jointed limbs that like dragonflies have. So I could not find any solid list of the definition of lobopods. By the strictest definition, with the smallest grouping, they didn't make it past the Cambrian, with more of like looser definition, including tardigrades and the velvet worms. The more recent papers I noticed refer to lobopens as including groups as tardigrade and velvet worms. This would make Hallucigenia an early relative, even if not a direct predecessor. And since then, there actually has been some changes. Okay, I guess there has been no change. So in 2015, a paper was published that has our current, at least in early 2025, understanding of Hallucigenia's basic anatomy. With advances in technology such as electron microscopy, scientists found out, first of all, what end is what. Not only did they find out where the head is, but they found certain anatomy such as eyes and digestive systems. Um, the club end actually turned out to be its gust essentially squished out. So the club end was its guts of when the critter was squished. Sorry for the disgusting mental image there. But the features such as there's features we discovered such as a pair of simple eyes, so not like compound flies or crabs have. They had a circular mouth, which is actually something that tardigrades have, so that's pretty cool. But I should address the lack of bones or hard structures holding up hallucinogen right now, like how I referred to them as tentacles earlier. It was probably held up with the hydrostatic skeleton. Since water does not compress a whole lot, it can be used as bone structures. Again, tardigrades have this. That's how they stand up on their little feetsies. Okay, yes, there have been other attempts, and there's to look at it. There have been other papers that really gave progress with describing this animal, but these are some of the bigger ones. Currently, there are three described species. Hallucigenia is a genus, with sparsa being found in Canada and Fortis, and I'm not going to pronounce that, being found in China. If you want more, I have resources linked below as a recording. I'm not sure if YouTube's convinced I'm a human. Apparently, this face is not beautiful enough to be human or something, or maybe I'm too beautiful. But so either in description or a pinned comment. Thank you for watching. I also have a link to my Discord so you can bully me to make sure I get more videos out or to tell me what videos to have. I'd like to say the coffee shop's on the left and something's on the right. My brain just stopped. My human brain just stopped. It's not because I ran out of RAM.
So I say do it. Do it! Do it, do it, do it!
I heard how much you dated your mom last night.